The Tupolev ANT-25 occupies a unique place in aviation history, not as a combat aircraft, but as a technological demonstrator that embodied the Soviet Union's ambitions to prove its engineering prowess on the global stage. Its development was closely tied to the political and strategic context of the early 1930s, when distance and endurance flights were seen as tools of both national prestige and practical exploration of future long-range bomber concepts. The ANT-25 emerged as a machine designed to break records, to demonstrate the feasibility of intercontinental flight, and to push the limits of Soviet aeronautical engineering in a period when the nation sought international recognition for its technical progress. The origins of the project lay in the broader program of experimental aircraft led by Andrei Tupolev and the Central Aerohydrodynamic Institute, TSAGI. The Soviet Union of the early 1930s was undergoing rapid industrialization under Stalin's 5-year plans, and aviation was singled out as a key sector symbolizing modernization. While Western nations celebrated endurance flights by aviators such as Charles Lindbergh, the Soviet leadership sought equivalent or greater achievements to showcase socialist industry. The ANT-25, therefore, was conceived not as a military production aircraft, but as a record-breaking platform that could demonstrate long-range potential. The design team under Tupolev faced several challenges. Creating an aircraft capable of flying thousands of kilometers non-stop required innovative solutions for aerodynamics, structure, and fuel storage. The ANT-25 was configured as a large, low-wing monoplane with an exceptionally high aspect ratio wing, over 34 meters in span, providing efficient lift at cruise speeds. The fuselage was slim and streamlined, minimizing drag. Most striking was the internal arrangement. Nearly half of the aircraft's takeoff weight consisted of fuel, carried in large tanks integrated into the wing and fuselage. Achieving the structural strength to hold this load while keeping the airframe light enough to fly was one of the central engineering breakthroughs. The power plant chosen was the Mikulin AM-34, a liquid-cooled V12 engine delivering around 900 horsepower. Reliability was paramount, as failure over remote regions could mean the loss of aircraft and crew. Engineers worked to optimize cooling, propeller efficiency, and fuel consumption, balancing power against endurance. Early calculations indicated that the ANT-25 could achieve ranges of over 12,000 kilometers, an extraordinary figure for the time. The cockpit arrangement reflected its purpose as a long-range endurance machine. A 3-man crew operated in a narrow fuselage, with provisions for rotating shifts during flights lasting several days. Space was cramped and comfort minimal, but the design prioritized functionality, clear instrumentation, navigation equipment, and basic accommodations for rest. The ANT-25 was not intended to fight or maneuver, but to endure. The first prototype took shape in 1932, and ground tests immediately revealed the scale of the undertaking. With a wingspan comparable to heavy bombers of the era, but a slender fuselage, the aircraft was unlike anything in the Soviet arsenal. Initial taxi trials demonstrated stability, but also highlighted issues with ground handling due to the long wings and relatively small undercarriage. Engineers reinforced the structure and refined the undercarriage to ensure safe operations on the uneven airfields of the Soviet Union. The ANT-25 thus emerged from its design phase as a machine unlike conventional military aircraft. It represented a convergence of aerodynamic efficiency, structural innovation, and political ambition. Conceived at a time when aviation was a contest of prestige between nations, it was a deliberate attempt by the Soviet Union to stake its claim as a leader in long-range flight. The aircraft's origins, therefore, were as much political as technical, a response to global achievements and a reflection of the Soviet state's desire to demonstrate both engineering capacity and ideological strength through aviation. The prototype of the Tupolev ANT-25 was completed in 1932, marking the transition from paper calculations to physical reality. Its sheer size immediately set it apart from contemporary Soviet aircraft. The wings, stretching more than 34 meters, gave the plane the appearance of a soaring glider rather than a conventional long-range bomber. Yet beneath the sleek form lay one of the most ambitious engineering experiments of its era. The testing program aimed to validate not only the structural integrity of such a design, but also the practical feasibility of flights measured in tens of thousands of kilometers. Initial ground tests reveal the delicate balance required between weight, stability, and durability. The aircraft carried vast quantities of fuel in integral tanks, and engineers were cautious about stresses on the wings and fuselage. Taxi runs on airfields demonstrated that while the ANT-25 could roll stably, its long wingspan posed difficulties in maneuvering on the ground. Adjustments were made to the landing gear and bracing to handle uneven Soviet runways. Equally important was ensuring the strength of the wing spar, which had to endure heavy loads over prolonged periods without deformation. The first flight trials, conducted under the supervision of experienced test pilots, confirmed both the promise and the challenges of the design. The ANT-25 achieved smooth takeoffs and landings, and in the air it displayed remarkable endurance characteristics, gliding efficiently at cruising speeds. However, issues with engine reliability quickly emerged. The Mikulin AN-34, though powerful, had to operate continuously for dozens of hours during long-range missions. Cooling and lubrication systems were tested rigorously, and modifications were introduced to improve stability in sustained operation. Engineers experimented with propeller pitch and engine settings to find the optimal balance between fuel consumption and thrust. One of the most critical stages of testing involved navigation and crew management during extended flights. The ANT-25 required 3 men, commander, co-pilot, and navigator, rotating responsibilities in a cockpit that offered little comfort. Long test flights over Soviet territory simulated the conditions of future record attempts. Crews reported fatigue, disorientation, and the physical strain of operating in a confined space for up to 70 hours. To mitigate these problems, procedures were developed for rest periods, meal consumption, and communication during flight. These early trials effectively turned the ANT-25 into a laboratory for studying human endurance in aviation. By 1934, the aircraft began to demonstrate its record-breaking potential. In September of that year, a crew led by Mikhail Gromov achieved a flight of 12,411 kilometers, remaining airborne for over 75 hours. This extraordinary achievement set a world distance record, instantly drawing international attention. The Soviet press celebrated it as proof of the nation's technological advancement, while foreign observers acknowledged the feat with respect. Still, questions remained about the practicality of such missions and the vulnerability of the design in real operational contexts. Further testing pushed the ANT-25 beyond national boundaries. In 1936, a flight from Moscow to the Far East covered over 9,000 kilometers, reinforcing the concept of intercontinental range. These flights provided invaluable data not only on the aircraft itself, but also on navigation techniques, meteorological forecasting, and radio communication over immense distances. Each mission exposed new technical weaknesses, from fuel system leaks to engine wear, and each required meticulous refinement by engineers. The testing program became iterative. Every problem encountered in the air was fed back into design improvements on the ground. By the late 1930s, the ANT-25 had proven itself capable of journeys no other aircraft could match. It had established records and shown that Soviet aviation was competitive with the most advanced nations. Yet the aircraft remained a specialized tool rather than a production model. It was too large, too slow, and too fragile to serve as a standard bomber or transport. Its purpose had been to prove what was possible, and in this regard, it succeeded. The testing era thus defined the ANT-25 not as a weapon of war, but as a symbol of experimentation, endurance, and national ambition. The data gathered during these years laid the foundation for future Soviet long-range bombers, translating lessons from record-breaking flights into the practical requirements of strategic aviation. When the Tupolev ANT-25 moved beyond its initial trials, it transitioned into the phase for which it had been conceived: spectacular long-distance flights that would demonstrate Soviet engineering to the world. Although never intended for mass production or combat deployment, the ANT-25 was pressed into service as a record setter, effectively acting as a diplomatic instrument of the Soviet state. Its first major operational use came in the mid-1930s, when crews of skilled aviators undertook flights designed to showcase the aircraft's extraordinary endurance. The Soviet leadership quickly understood that long-range aviation could serve as a tool of political influence. In an era when aviation records captured global headlines, distance and endurance flights were used to project power without firing a single shot. The ANT-25 thus entered service not with squadrons or combat units, but as part of carefully organized expeditions. The most famous of these took place in 1937, when Valery Chkalov and his crew flew nonstop from Moscow to Vancouver, Washington, crossing the Arctic and covering over 8,500 kilometers in 63 hours. The flight was unprecedented not only for its distance but also for its route across the polar regions, demonstrating both navigational skill and the resilience of Soviet technology in extreme conditions. This flight was followed shortly by another, commanded by Mikhail Gromov, which stretched even further, from Moscow to San Jacinto, California, covering 10,148 kilometers over the Arctic in 62 hours. Both missions made international headlines and were celebrated in the United States as well as in the Soviet Union. American officials received the crews warmly, recognizing the flights as milestones in aviation history. For the Soviets, these missions had enormous propaganda value. They presented the USSR as an advanced technological nation capable of achievements rivaling or surpassing Western aviation powers. Pilots' reports from these missions provide insight into the operational realities of the ANT-25. Conditions on board were austere. The narrow fuselage and confined cockpit allowed little room to move, and shifts had to be organized carefully to prevent exhaustion. Meals were taken from simple rations, and navigation required constant calculation, often under fatigue. The crew relied heavily on celestial navigation and radio signals, especially over the featureless expanse of the Arctic. The endurance required was not only mechanical but also human, as pilots fought drowsiness, discomfort, and the monotony of endless hours in the air. Reactions from military leaders were mixed. On the one hand, the flights demonstrated the possibility of intercontinental aviation, with implications for both strategic bombing and global reach. The concept of flying across the polar regions to strike distant targets was suddenly no longer theoretical. On the other hand, the ANT-25 itself was not a practical military aircraft. It was slow, vulnerable, and unsuited to combat roles. Nonetheless, the lessons drawn from its operation informed Soviet long-range aviation doctrine. Strategic planners began to consider how such range could be applied to bombers designed specifically for war. Internationally, the ANT-25's missions helped soften foreign perceptions of the Soviet Union. The arrival of Soviet crews in the United States in 1937 created a rare moment of goodwill during an otherwise tense interwar period. Crowds greeted the aviators with enthusiasm, newspapers praised their courage, and officials highlighted the flights as symbols of cooperation. For the Soviet Union, these expeditions were invaluable in presenting an image of modernity and capability at a time when it sought recognition as a world power. In operational terms, then, the ANT-25 entered service not as a weapon but as a messenger. Its long-range flights functioned as demonstrations of potential rather than direct contributions to combat readiness. The aircraft served as a bridge between the experimental stage and the strategic visions of future aviation. While it never carried bombs into battle or patrolled in combat zones, it carried something equally important: the message that the Soviet Union had entered the forefront of global aviation. The flyer had opened the sky for humanity. The ANT-25 extended that horizon across continents and oceans, redefining what long-range flight could mean in both political and military terms. The Tupolev ANT-25 was never conceived as a frontline combat machine, yet its endurance flights immediately provoked discussion about how such an aircraft, or its successors, might be adapted for wartime purposes. Within the Red Air Force, the extraordinary ranges demonstrated by Chkalov's and Gromov's polar missions stimulated interest in intercontinental operations, particularly in the concept of striking distant targets by flying routes over the Arctic. Though the ANT-25 itself lacked the speed, payload, and defensive armament to operate in hostile skies, it provided a practical proof of concept for strategic doctrines that would influence Soviet planning well into the Second World War. In theoretical terms, the ANT-25's ability to fly across oceans and continents suggested new options for Soviet strategy. One line of thought considered the possibility of developing polar bomber routes that could reach North America, bypassing conventional naval defenses. Another explored the role of long-range reconnaissance and propaganda flights, demonstrating to allies and adversaries alike that the Soviet Union could project its presence far beyond its borders. The ANT-25 did not carry out such missions itself, but its record flights acted as rehearsals for the idea that aviation could circumvent geographic constraints. Operational experiments were conducted to test the feasibility of adapting long-range designs for military purposes. Engineers studied whether the ANT-25's airframe could be modified to carry payloads of bombs or reconnaissance equipment. In practice, the aircraft's limited structural strength and single-engine configuration imposed severe restrictions. The heavy fuel load necessary for extreme distances left little margin for useful payload, and its cruising speed of around 240 kilometers per hour made it highly vulnerable to interception. As a result, the ANT-25 never entered combat and was never seriously considered for frontline deployment. Nonetheless, the data gained from its operation directly informed the development of later Soviet long-range bombers. The Petlyakov TB-7, later designated PE-8, which became the Soviet Union's only four-engine strategic bomber of the Second World War, drew on lessons from the ANT-25 program in terms of fuel management, crew endurance, and navigation over great distances. Similarly, Soviet interest in transpolar flight routes, first demonstrated by ANT-25 missions to the United States, resurfaced in wartime discussions of ferry flights, long-range reconnaissance, and the possibility of striking German or Japanese targets beyond conventional ranges. From a tactical perspective, the ANT-25's legacy lay less in its direct application than in the operational practices it forced crews to develop. Pilots and navigators had to master celestial navigation, radio coordination, and fatigue management during flights lasting over 2 days. These techniques, tested under record-setting conditions, later became essential in long-range bomber units. Soviet commanders recognized that while the ANT-25 itself could not deliver bombs, it had trained aviators and engineers in the practical challenges of endurance missions, knowledge that transferred to wartime operations. The symbolic impact of the ANT-25's achievements also influenced Soviet wartime propaganda. The long polar flights of 1937 remained celebrated during the war years, often cited as evidence that Soviet aviation had long been capable of feats unmatched by foreign powers. Although frontline aircraft like the PE-2 dive bomber and Il-2 ground attack aircraft bore little resemblance to the ANT-25, the narrative of Soviet long-range capability helped sustain morale and reinforce the image of technological strength. In the end, the ANT-25's combat role was indirect but significant. It never flew armed sorties, yet its design philosophy, operational lessons, and symbolic value contributed to the evolution of Soviet long-range aviation. The endurance flights demonstrated that vast distances could be overcome, and they provided the intellectual foundation for later strategic thinking. In this sense, the ANT-25 served as a bridge between the era of record-breaking aviation and the practical demands of global warfare, proving that the concept of intercontinental flight was not merely theoretical but achievable, even if the aircraft itself remained unsuited for combat. As the ANT-25 fulfilled its purpose as a record-breaker and diplomatic tool, attention shifted toward how its unique configuration might be refined and what lessons could be carried forward into new designs. Although only a handful of ANT-25 airframes were ever built, the program produced a surprising number of variants, experimental modifications, and derivative concepts that shaped Soviet aeronautics throughout the 1930s. The primary version, sometimes referred to as the RD for Record Dalnosti or Range Record, embodied the long-range endurance design with its immense high aspect ratio wing and single Michelin AM-34 engine. But as flights accumulated, engineers began to explore adjustments aimed at improving efficiency and safety. Fuel capacity and distribution were refined to balance weight more effectively across the long wingspan, reducing stresses during turbulence. Attention was also given to structural reinforcements, since early records revealed the vulnerabilities of thin spars carrying enormous loads for dozens of hours in continuous flight. One important line of development was the RD-1, which incorporated improvements to the AM-34 engine, including better cooling and modifications to reduce fuel consumption. This reflected the central challenge of all long-range aircraft. Engines of the 1930s were not designed for uninterrupted operation over 70 or more hours. Soviet engineers treated the ANT-25 as a platform to test incremental power plant refinements, and the data gathered informed later bomber and transport engines. There were also experimental concepts aimed at increasing crew survivability and endurance. For example, the idea of pressurized cabins was raised during the ANT-25 era, though it was not realized on the aircraft itself. Insulation, heating, and radio equipment were gradually improved to make long polar flights more manageable. The cramped conditions of the baseline ANT-25 underscored the need for more ergonomic layouts in future long-range designs, lessons that later influenced the Petlyakov TB7 and its successors. Beyond technical refinements, the ANT-25 also inspired derivative projects. Tupolev's design bureau explored the possibility of scaling the concept into a multi-engine platform capable of carrying both crew and payloads more effectively. The TB4 and TB7 bomber programs carried forward the ANT-25's emphasis on range and endurance, but applied it to heavier, combat-ready configurations. The ANT-25 was thus less an isolated record machine and more a stepping stone toward a lineage of Soviet long-range aviation. International comparisons highlighted the uniqueness of the ANT-25. While Western nations pursued transatlantic flights using modified transports or bombers, few designed a purpose-built single-engine record aircraft of comparable endurance. The ANT-25's specialized wing and fuel distribution system were distinctly Soviet solutions to the global challenge of range. Though never exported or produced abroad, the aircraft influenced discussions in Europe and the United States about polar routes, long-range patrols, and the feasibility of strategic bombing from remote bases. By the late 1930s, however, aviation technology was evolving rapidly. The ANT-25's low cruising speed and fragile airframe limited its potential, even as it remained a useful research tool. Multi-engine designs became the standard for long-range roles, offering redundancy, higher payloads, and greater flexibility. In this context, the ANT-25's variants were viewed as transitional experiments rather than enduring platforms. Still, its contribution to technological evolution was undeniable. Every modification, whether to engine, structure, or equipment, added to the Soviet knowledge base in areas crucial for the looming demands of global conflict. The ANT-25 demonstrated that range could be achieved with careful engineering, but it also revealed the limitations of relying on a single-engine endurance craft. The pursuit of variants and derivatives transformed the aircraft from a mere record breaker into a research vehicle whose influence reached well beyond the handful of airframes built. In doing so, it bridged the gap between demonstration flights and the practical requirements of strategic aviation, ensuring its place in the broader narrative of 20th century aerospace development. The Tupolev ANT-25 ultimately achieved significance less through its limited production than through the global attention it generated and the legacy it left behind. In an age when endurance flights captured headlines around the world, the ANT-25 placed the Soviet Union firmly in the narrative of aviation progress. The polar crossings of 1937 were not merely technical achievements, they became symbols of national power, shaping international perceptions of the USSR as an advanced and modern state. The airplane thus bridged the gap between technology and geopolitics, showing how an experimental machine could become an instrument of diplomacy. The global impact was most visible in the United States. The landings of Chkalov's and Gromov's crews in Washington and California were celebrated with ceremonies, parades, and official receptions. At a time when U.S.-Soviet relations were strained by ideological differences, the flights created rare moments of goodwill. American media praised the courage of the Soviet aviators, while military and engineering communities studied the technical data with interest. For the Soviet Union, these missions achieved exactly what they had intended: international recognition of their engineering capabilities and a demonstration that Soviet aviation could rival or surpass Western achievements in range. Within the Soviet Union, the ANT-25 became a cultural icon. The names of its pilots were celebrated in newspapers, films, and literature, presented as heroes of the socialist state. The flights were used as propaganda to inspire confidence in Soviet industry and to highlight the achievements of collectivist labor and scientific planning. The ANT-25 appeared on posters, stamps, and commemorative medals, ensuring that its image reached millions of citizens. This symbolic power was as important as its technical record, embedding aviation into the broader narrative of Soviet modernity. From a doctrinal perspective, the ANT-25's legacy lay in the strategic imagination it encouraged. The idea of using polar routes to reach distant continents influenced Soviet thinking about intercontinental aviation for decades. Even after the aircraft itself was obsolete, its record flights remained reference points in discussions about bomber development and Arctic exploration. The Petlyakov PE-8 and later long-range strategic bombers of the Cold War inherited the conceptual foundation demonstrated by the ANT-25, that great distances could be conquered and that polar navigation was both possible and strategically valuable. The ANT-25 also contributed to broader developments in international aviation. Its record flights pushed the boundaries of navigation, meteorology, and endurance, generating knowledge that informed not only military strategy but also civil aviation. The techniques of polar flight, refined with the ANT-25, would later prove essential for establishing transpolar airline routes after the Second World War. In this sense, the aircraft was not merely a Soviet achievement but part of the global process of expanding aviation's horizons. After its retirement, surviving examples of the ANT-25 were preserved as museum pieces, displayed as milestones in the history of flight. In Russia, the aircraft's memory has been maintained through exhibitions at aviation museums and commemorative sites. Abroad, references to the ANT-25 appear in historical accounts of polar aviation and long-range records, where it is remembered alongside Western endurance aircraft of the same era. Its survival as a cultural and historical symbol has outlasted its brief operational life. The ultimate legacy of the ANT-25 is that it demonstrated the fusion of engineering, politics, and symbolism in aviation. It was never a frontline weapon, yet it altered strategic thinking. It was never mass-produced, yet it shaped perceptions of Soviet modernity. It was, above all, a record breaker that turned technical endurance into a tool of international prestige. By opening polar routes, demonstrating intercontinental range, and capturing the imagination of millions, the ANT-25 secured its place in aviation history as the Soviet long-range record breaker that proved the sky could be crossed in ways previously unimaginable. Beyond its celebrated record flights and symbolic presence, the Tupolev ANT-25 also generated a series of lesser-known stories and experimental uses that reveal how the aircraft functioned as a testbed and a bridge between eras of aviation. These unseen chapters demonstrate that while the ANT-25 was never intended for combat or large-scale production, it continued to contribute to Soviet aeronautics in ways that often escaped the spotlight. One such chapter concerned its role in research on navigation and communications. Long-range polar flights required reliable methods of orientation in regions where magnetic compasses became unreliable and landmarks were absent. ANT-25 missions served as real-world laboratories for testing celestial navigation techniques and early radio beacons. Crews developed procedures that were later adopted by both military and civil long-range aviation. These experiments were rarely publicized but became vital to the eventual establishment of transpolar airline routes and wartime ferry flights across the Arctic. Another forgotten dimension was the exploration of possible military adaptations, although engineers recognized that the ANT-25's single-engine design and fragile frame made it unsuitable for bombing or reconnaissance. There were proposals to use it for experimental roles. Discussions were held about equipping the aircraft with cameras for long-range aerial surveys of remote Soviet territories, particularly in Siberia and the Arctic. While little concrete evidence survives that such missions were carried out extensively, the concept of using ANT-25 airframes as survey aircraft indicates how the design was considered for practical purposes beyond propaganda flights. The aircraft also appeared in proposals for successor projects that were never fully realized. Engineers at Tupolev's bureau examined the possibility of developing multi-engine derivatives that could combine the ANT-25's endurance with practical payload capacity. Some of these ideas influenced later strategic bomber programs, though the ANT-25 itself remained confined to its record-breaking role. The line between a research prototype and a true operational platform was never crossed, but the lessons learned informed the transition. In the realm of aviation culture, the ANT-25 inspired a wave of commemorative activity. Soviet newspapers devoted serialized accounts to the long flights, and schools often included lessons about the aircraft in curricula celebrating national technological achievements. Less well known are the small-scale replicas and models constructed for exhibitions and educational purposes across the Soviet Union, ensuring that children and enthusiasts could physically encounter a representation of the machine that had carried the Soviet flag across the polar skies. There were also symbolic connections that extended the ANT-25's influence into later decades. Portions of surviving airframes preserved in museums became touchstones for Soviet aviation identity. Test pilots and engineers of later generations often reference the ANT-25 as a source of inspiration, seeing in its flights the moment when Soviet aviation first achieved global recognition. Some even regarded it as a spiritual predecessor to the long-range missions of the Cold War, when bombers and space vehicles extended the same logic of endurance and reach into new domains. Finally, the ANT-25 story includes the reality of obsolescence. By the outbreak of the Second World War, the few surviving airframes were outdated, overshadowed by modern bombers and transports. They were quietly retired, but their symbolic legacy endured. Unlike many experimental aircraft that vanish into obscurity, the ANT-25 remained present in Soviet collective memory because of its association with heroism, exploration, and record-setting achievement. Its unseen chapters lie in these quieter roles, supporting research, influencing doctrine, inspiring engineers, and becoming a cultural icon beyond its technical life. Thus, the ANT-25's forgotten missions and experimental uses round out its history. It was more than a single-purpose record breaker. It was a tool of exploration, a subject of adaptation, and a symbol woven into the wider narrative of Soviet technological ambition. In these hidden contributions, the ANT-25 continued to shape aviation long after its final endurance flights had ended. By the time the ANT-25 had completed its most famous polar missions, its direct operational use was limited, yet its broader cultural and strategic meaning continued to resonate. In the Soviet Union, the aircraft became a symbol not just of aviation, but of the industrial and ideological progress that the state wanted to project, both internally and abroad. This cultural significance ensured that the ANT-25 was remembered long after its few airframes had disappeared from active use, and its place in history was defined as much by perception as by performance. Domestically, the ANT-25 and its pilots were woven into the Soviet narrative of technological triumph. The record flights of 1937 were used as propaganda milestones portrayed in newspapers, books, and public speeches as evidence that socialism could achieve world firsts in science and engineering. Chkalov, Gromov, and their crews were celebrated as heroes of the state, becoming national figures whose exploits were taught in schools and memorialized in films and literature. The ANT-25 itself appeared on posters and stamps, its distinctive long wings instantly recognizable to millions. The aircraft thus transcended its technical role, becoming a cultural icon that reinforced the legitimacy of Soviet modernization efforts. Internationally, the aircraft carried a similar symbolic weight. In the United States, where the flights concluded, the reception was warm and often enthusiastic. Media coverage emphasized not only the courage of the crews, but also the technological sophistication of the aircraft. These episodes temporarily softened political tensions and created a rare moment of mutual admiration between two nations ideologically opposed. In Europe, the ANT-25 was viewed with respect, even as rival aviation powers sought to outdo the Soviet record with their own achievements. In this sense, the aircraft became part of a global competition where endurance flights served as measures of national prestige. The ANT-25 also contributed to the evolution of Soviet doctrine in ways that went beyond immediate utility. The concept of polar routes, which had been demonstrated so dramatically, remained in Soviet strategic planning for decades. In the Cold War, long-range bombers and later intercontinental missiles would rely on polar trajectories to reach distant targets, validating the vision first embodied by the ANT-25's flights. While the aircraft itself could never have carried out a strategic bombing mission, the principle it proved, that the polar regions were not barriers but pathways, endured as one of its greatest contributions. In the realm of technological legacy, the ANT-25 was a teacher rather than a prototype for production. It revealed the limitations of single-engine endurance aircraft, highlighted the human and mechanical challenges of flights exceeding 60 hours, and exposed the vulnerabilities of thin, structural designs carrying immense fuel loads. These lessons directly inform the development of the PE-8 and other Soviet long-range bombers, which were conceived with multiple engines, heavier structures, and better provisions for crews. In this way, the ANT-25 was a transitional figure, not the end in itself, but the experiment that pointed toward the requirements of true strategic aviation. Its place in museums further reinforced its cultural role. Surviving airframes and replicas were displayed in institutions dedicated to Soviet aviation, where they were presented not only as engineering achievements but also as artifacts of national pride. Visitors encountered the ANT-25 as part of a narrative that linked it to broader achievements in science, exploration, and eventually spaceflight. Its story was deliberately framed as a foundation for later triumphs, a starting point from which the Soviet Union advanced toward ever greater heights. Thus, the ANT-25's global impact and legacy lay in its dual nature. As an aircraft of limited direct utility, but of immense symbolic and doctrinal influence. It proved what was technically possible, inspired generations of aviators and engineers, and secured a permanent place in the cultural memory of both the Soviet Union and the wider world. The ANT-25's long wings carried it into the record books, but its lasting flight was into history itself, where it remains a reminder of how a single machine can redefine the boundaries of imagination, strategy, and identity. The twilight years of the Tupolev ANT-25 were marked not by active missions but by the consolidation of its historical role and the preservation of its story in collective memory. By the outbreak of the Second World War, the aircraft was already outdated in practical terms. Advances in aeronautical engineering had produced faster, more reliable multi-engine bombers capable of carrying significant payloads, while the ANT-25 remained a specialized single-engine endurance craft. Nevertheless, its achievements were too significant to allow it to fade into obscurity, and so the aircraft transitioned into the realm of commemoration and legacy. In operational terms, the remaining ANT-25 airframes saw little, if any, wartime service. The fragile design, dependent on long, paved runways and extended flight preparation, was unsuited to the demands of combat. Instead, Soviet wartime aviation focused on platforms such as the PE-2, IL-2, and the PE-8, which drew indirectly on the research lessons of the ANT-25 but were built for the realities of combat. What survived of the ANT-25 fleet was relegated to testing duties, training roles, or storage. The aircraft had served its symbolic purpose in peacetime. Wartime required machines of a different nature. Post-war, the Soviet Union carefully preserved the narrative of the ANT-25 as a national triumph. Museums in Moscow and other cities restored surviving examples or built replicas to display to the public. The aircraft was shown alongside portraits of its crews, emphasizing the heroism of Chkalov, Gromov, and their fellow aviators. Exhibitions placed the ANT-25 in a continuum of progress, linking it to the subsequent rise of Soviet strategic aviation and even to achievements in space exploration. This narrative reinforced the notion that the record-breaking flights of the 1930s had been essential steps on the path to later technological victories. The commemoration extended beyond physical preservation. School textbooks of the post-war period devoted chapters to the ANT-25, presenting it as proof that Soviet science could conquer distances once thought impossible. Literature and cinema often referenced the polar flights, framing them as both daring human adventures and ideological triumphs. The aviators themselves were immortalized as cultural icons, with monuments erected in their honor. Through these representations, the ANT-25 became less a machine and more a myth, an emblem of national resilience and ambition. Internationally, the memory of the ANT-25 endured in aviation histories that recorded its world records and polar crossings. While Western accounts were often less overtly celebratory than Soviet sources, they nonetheless acknowledged the technical significance of the aircraft. Aviation historians noted that the ANT-25 was among the first to demonstrate reliably that intercontinental flight was possible via polar routes, a concept that would later underpin global airline networks and Cold War strategic doctrines. Thus, even as the aircraft itself disappeared from runways, its influence continued in academic and technical discussions. The final legacy of the ANT-25 lies in its enduring presence as a symbol rather than as a functioning airframe. Unlike combat aircraft whose reputations were built in battles, the ANT-25's fame derived entirely from record-setting achievements and the political narratives that surrounded them. It demonstrated that technological experiments could achieve cultural immortality when aligned with national goals. Its few airframes may have been retired quietly, but the memory of its flights was preserved with care, ensuring that the ANT-25 would forever occupy a place in the history of both aviation and Soviet identity. In this way, the ANT-25 story concluded not in obsolescence, but in transformation. From prototype to record breaker, from diplomatic tool to museum exhibit, it traced a trajectory that mirrored the evolution of aviation itself, from fragile beginnings to lasting cultural institution. The aircraft that once crossed the polar sky now rests in the annals of history, remembered not for combat victories, but for proving the boundless potential of human engineering and endurance. The full story of the Tupolev ANT-25 reveals an aircraft that existed on the boundary between experiment and symbol, more famous for what it represented than for what it directly achieved in service. In the technical sense, it was a limited machine, slow, fragile, and wholly unsuited to the rapidly changing demands of military aviation. Yet in the cultural, strategic, and historical sense, it was a success of the highest order. Its long, thin wings carried not bombs but a message that the Soviet Union had entered the ranks of advanced aviation powers, capable of matching and even surpassing the feats of other nations. The ANT-25's true achievement was the way it extended the horizons of what was considered possible. The intercontinental flights across the Arctic proved that distance could be overcome, that polar routes were viable, and that human crews could endure days in the air with careful planning. These demonstrations, though not directly transferable to combat, fed directly into the intellectual foundation of Soviet long-range aviation. When the PE-8 heavy bomber took shape, and when Cold War planners later considered intercontinental bomber and missile routes, the echoes of the ANT-25's polar crossings were unmistakable. It had shifted the strategic imagination of an entire generation. Culturally, the ANT-25 exemplified the Soviet use of technology as propaganda. Its record flights became national triumphs, transforming individual aviators into celebrated heroes, and the aircraft itself into a symbol of socialist achievement. In a period of rapid industrialization, the ANT-25 showed ordinary citizens that their country could lead in fields once dominated by the West. That symbolic function gave the aircraft a life far beyond its brief operational career. Its silhouette appeared in classrooms, museums, and commemorations for decades, ensuring that it remained familiar even to those with no memory of its flights. On the international stage, the ANT-25 played a subtle but important role in diplomacy. The goodwill generated by the Soviet crew's receptions in the United States was short-lived, but it demonstrated that aviation records could serve as tools of soft power. The aircraft's ability to capture headlines and inspire admiration abroad gave the Soviet Union a rare moment of positive global attention at a time when it was often viewed with suspicion. This diplomatic use of aviation would continue in later decades with space exploration, where Soviet achievements were similarly broadcast as signs of technological leadership. In retrospect, the ANT-25 also occupies a distinct place in the wider history of aviation. Alongside Lindbergh's Spirit of St. Louis, the German endurance flights of the 1930s, and the long-distance experiments of French and Italian aviators, the ANT-25 belongs to the era when aviation records were a stage for national prestige. Unlike those contemporaries, however, it carried with it a uniquely Soviet blend of political purpose and scientific experimentation. Its contribution was not measured in production numbers or combat missions, but in the way it redefined the relationship between distance, endurance, and strategy. By the time of its retirement, the ANT-25 had already become obsolete, but obsolescence did not diminish its importance. Instead, it transitioned seamlessly into history, remembered not as a failed prototype, but as a record breaker, a precursor, and a symbol. In museums and in memory, it endures as the aircraft that proved the Soviet Union could conquer distance. Its story serves as a reminder that some machines shape history not through combat, but through vision. By demonstrating the possible inspiring future designs and embedding themselves in the cultural imagination of their age. Thus, the ANT-25's ultimate legacy is that of a pioneer. It was never a weapon, never a mass-produced machine of war, but it fulfilled a vital role in the evolution of aviation. It pushed the boundaries of flight, carried Soviet pilots into history books, and ensured that the Soviet Union could claim its place on the global aviation map. In the balance of technological development and symbolic achievement, the ANT-25 stands as one of the great record breakers of the 20th century, remembered as the Soviet aircraft that carried endurance itself into the skies.